All right, honors chemistry people, we are going to do pretty much the opposite of what I taught you to do in the last video. In the last video, we were taking chemical compound formulas and learning how to generate mass percent of each of the constituent elements. Now what I'm going to ask you to do is take the mass percent of constituent elements and then generate me a formula for the compound. So to do that, we use what is called an empirical formula. I want to introduce the concept of empirical formulas right now. So the definition of empirical formula is right here. So let me get a tool out so that I can draw. So empirical formulas of a compound give us the smallest whole number ratio between the numbers or moles of atoms in different elements in a compound. So hopefully by now you've realized that the subscripts that we've been putting in can either designate number of moles in a mole of a compound of each of the constituent elements, or if we're talking about atoms, it can designate the number of atoms of a particular element in the compound. Okay? For example, the empirical formula for the compound benzene is C6H6. We have a common factor in 6 and 6, don't we? It is 6. So if I divide both of them by 6, I get one of each. I will get one carbon and one hydrogen. The empirical formula for hydrogen peroxide is H2O2. We have a common factor of 2. So if I divide by 2, I get one hydrogen and one oxygen. So that empirical formula would be HO. The empirical formula for table salt, NaCl, I have one of each. So I can't simplify beyond 1 because 1 is the smallest whole number that I have. So it's still NaCl. Okay, the empirical formula of a compound can be determined by experimentally finding the composition of the compound. And we do that by what we call mass spectrometry. And a lot of companies will do that, but we're just going to go with data. I want to give you one more example of an empirical formula. So if we look at glucose, and glucose is probably a molecule that you're relatively familiar with from biology, we had C6H12O6, right? That was always the end product of photosynthesis or the beginning product of cellular respiration. Do you guys remember that? So what is the common factor between 6, 12, and 6? Hopefully you all said 6. Okay, so if I divide 6 on the carbons, I get 1 carbon. If I divide by 6 on the hydrogens, I get 2 hydrogens. And if I divide by 6 on the oxygens, I get 1 oxygen. So what is a general name for sugars and starches? Hopefully you said carbohydrates. Right? You see this? 1 carbon. And what, pray tell, is H2O? Isn't it water, which is a hydrate, right? When you hydrate something, you water it. So that's why carbohydrates have the name carbohydrates, because the empirical formula is 1 carbon for every water. Okay? So let's go for some examples. Now today you're going to need a lot of math. So we're going to need a calculator. So make sure you have a calculator handy. Okay. So a compound is found to contain 46.56% iron and 53.44% sulfur by mass. Okay. From this data, find the empirical formula. So the easiest thing we're going to do is we are always going to pretend, if we have mass percents, we're going to always pretend that we have 100 grams of whatever compound we're talking about. So if I have 100 grams of this stuff, how many grams of that would be iron? Wouldn't I just have to do 46 46.56 grams of iron. And wouldn't that also give me 53.44 grams of sulfur? So if we always pretend that we have 100 grams of whatever we're dealing with, we can just use the percentages as mass, as grams. Okay? So the empirical formula is the smallest whole number mole ratio. So we need to calculate the number of moles of each of these elements present. So to get that, we also need to have our periodic table handy. So I want to take my 46.56 grams, and remember I did that through this, and I want to get that into moles. So I need to look up on my periodic table the amount of grams there are in iron. So I'm going to look here, and when I look at iron, remember we're going to the hundredths. I have 55.845. That 5 tells me to round up, so 55.85. So we're going to use 55.85. So I have 55.85 grams of iron in 1 mole of iron. Okay, now my grams cancel and I've got moles, which is exactly what I want. So I'm going to take 46.56 and I'm going to divide by 55.85. Okay, so this will give me 0.83366. And I'm going to carry 1 extra digit on my sig figs. Okay, because I don't want my mole ratios to fudge from rounding too much. Okay, we're going to do the same thing with sulfur. Okay, so if I do sulfur, let's look at sulfur on my periodic table. Sulfur, I have 32.066, so that's going to round to 32.07. So in 1 mole of sulfur, I have 32.07 grams of sulfur. Notice my grams of sulfur cancel and I'm into moles, which is what I want. So I'm going to take 53.44 and I'm going to divide it by 32.07. And I get this. I get 1.6663 moles of sulfur. Okay, now the thing is, what do I do from here? I have moles. Isn't a formula a ratio between moles? How do I create a ratio? Ratios are created by dividing, aren't they? So what I need you guys to do now is we need to find the smaller of the amount of moles, and we're going to use that as our divisor. So hopefully you realize that the amount of moles that we have of iron is smaller than the amount of moles that we have in sulfur. So we're going to use that as our divider. So I'm going to divide by 0.83366 on both of these. And when I do that, anything divided by itself is 1, isn't it? And here on these ratios, I'm wanting whole numbers as much as possible. It will get tricky in a bit, but for this one, we're wanting whole numbers. So I'm going to take 1.66, and hopefully you can do that pretty much in your head. Isn't this like 16 and this is like 8? So isn't this going to be 2? Let's plug it in our calculator really quick. So 1.6663 divided by 0.8336, I get 1.9989. That's really, really close to 2. Like super close to 2. So that's close enough. If we're within a tenth, use the nearest whole number. So this gives me my ratio of moles. And isn't a subscript really a ratio of moles? Isn't that what I told you guys up here? Isn't this a ratio of moles with the subscript in our formula? So that means I can write my formula with 1 iron and 2 sulfurs. Okay? So that would give me my formula of 1 iron and 2 sulfurs. My ratio right there. Okay? So that is an empirical formula. We're just going to use mole ratios to create a formula. And remember, notice how I wrote the metal first? We always write the metal first and the non-metal second. You guys want to take some practice and figure out what the name would be? So iron's a transition metal, right? Sulfur, on the other hand, is a -2. So if I have 2 sulfurs on that, wouldn't that be iron 4 sulfide? Because 2 -2s would give me a -4, so that would mean the iron would have to be a +4. So I shouldn't write the formula iron 4 sulfide. Okay, that's the empirical formula. So here we go. Let's do another example. What is the empirical formula of a compound containing 36.5% sodium, 25.4% sulfur, and the rest oxygen? How do I figure out that number? Don't I just take 100 minus these other 2 numbers to get that? Yeah, so let's do that really quick. So I'm going to take 100 and I'm going to subtract 36.5 and also subtract 25.4. That gives me 38.1. So I know I have 38.1% oxygen. Okay, so that's how we're going to start. So the next thing we have to do, we're going to pretend like we've got 100 grams of this stuff. So if I've got 100 grams of this stuff, that means I have 36.5 grams of sodium, and I've got 25.4% grams of sulfur and 38.1 grams of oxygen. Let's work on getting our sodium in moles. So I want moles of sodium on the bottom, or grams to cancel out, and I want moles on the top. I am misspeaking all the time today. So sodium, 22.990. So grams of sodium on the bottom to cancel out, and we decided it would 22.99 grams in 1 mole of sodium. So let's do the math here. So when we do that, we get, let's see, 36.5 divided by 22.99 gives us 1.587 moles of sodium. Now we get to do the same thing with sulfur. So I just miswrote that. Why won't that erase? Okay, 25.4 grams of sulfur. And when we looked up sulfur last time, it was 32.07 grams of sulfur in 1 mole of sulfur. So let's do that really quick. So 25.4 divided by 32.07 gives us 0.792 moles of sulfur. And then we're going to do oxygen. So 38.1 grams of oxygen. And in 1 mole of oxygen, let's look up her mass of oxygen again. Oxygen, 15.999, we'll round to 16.0. Hopefully you have some of these memorized by now. 16.00 grams of oxygen is what we're going to divide by. So 38.1 divided by 16.0 gives us 2.381 moles of oxygen. Now, do you remember what the next step is? The next step is to create our ratio. So we need to find our divisor. Remember which one we use for our divisor? It is the least amount of moles. So we are going to use sulfur, the amount of moles of sulfur for our divisor. So I'm going to divide all of these by 0.792. Now, anything divided by itself will give me 1, right? So I will get 1 ratio for sulfur. Now, if I take 0.792 and divide what we just did, 2.381, I get 3.0066. That's pretty dang close to 3. So we're going to call that 3. And if I take 1.587 and divide by 0.792, that's 2.0037. So that's really, really close to 2. That's our whole number. So there's our whole number ratio. We have 2 sodiums, 1 sulfur, and 3 oxygens. So when we write a formula, remember we are always going to start with you guessed it, the metal. So we'll start with sodium. Then I'm going to write sulfur, and then I'm going to write the oxygen. I need to put a subscript of 2. Did you guys catch that? I didn't put my subscript of 2 with my sodium. So how would we name this? SO3 is a polyatomic. Do you remember what its name was? Sulfite. So this is sodium sulfite. So we just figured out the formula just based on mass percent of sodium sulfite. Okay, example 10. This circle graph below gives the percent composition for a blue solid. We don't know really what it is. Wow, what happened to my notes? Wow, what happened? Give me a second, guys. Let's save this, I think. Let's reopen it up. Let's go back to where we were. Okay. Oh, I see. It had skipped ahead a bunch. All right, here we are. Sorry. Not fun. Okay, the circle graph below gives the percent composition for a blue solid. What is the empirical formula? So we know that we have 63.16% oxygen, and we know that we have 36.84% nitrogen. We just need to pretend that we've got 100 grams of this stuff. So what's my next step? Do you say to get moles? Yeah, we do. So 63.16 grams, we're going to pretend that we've got 100 grams of this stuff. So we would have 63.16 grams of oxygen. And if you remember from our previous example, we had 16 grams of oxygen in 1 mole of oxygen. So we're going to take 63.16 and we're going to divide it by 16. So this gives me 3.9475 moles of oxygen. Okay, and I'm going to do the same thing for nitrogen. I've got 36.84 grams of nitrogen. And in 1 mole of nitrogen, how many grams do we have? Do you guys remember? Let's look up. So nitrogen, 14.007 will round to 14.01. So 14.01 grams of nitrogen. So I'm going to take 36.84 and divide by 14.01. This gives me 2.6295 moles of nitrogen. Now, do you guys remember what the next step is? That next step is to find our ratio by dividing by our least amount of moles. Which one's smaller? Nitrogen's smaller. So we are going to divide by the amount of moles that we have for nitrogen. So anything divided by itself is going to be 1. So let's take the 3.9 and we're going to divide it by 2.62. Okay, so 3.9475 divided by 2.6295 is going to equal 1.5. But that's not even close to a whole number. So what do I do if it's not close to a whole number? Remember I said it needed to be within a tenth? So what can I multiply 1.5 by to make it a whole number? Can I multiply it by, what's 1.5 times 2? Isn't it 3? So if I multiply this by 2, that means I also have to multiply the others, all the other elements by 2. So 1 times 2 is 2. So this is my simplest whole number ratio. So that means I have 3 oxygens and I have 2 nitrogens. So I am going to write the least electronegative element first, which is nitrogen. So 2 nitrogens and 3 oxygens. What would this be called? This is a nonmetal bound to a nonmetal. So we're going to use covalent names, right? So this is dinitrogen trioxide. How'd you do on that name? Did you do okay? All right, that is it for now. I'm going to make another video helping us learn how to do molecular formulas. See you in a few. Bye.